Hello and welcome back to the Guns and Glory Show. It is April the 3rd, 2026. I have a proper propeller project at hand today. Built this machine to measure the thrust from the propellers and the motors. So I got a hold of all 6 of the motor sizes that I have, and I started 3D printing every different propeller that I could find until I got a couple that would work well. I had one set that just wouldn't produce the thrust. I think the surface of the prop was too rough, so I ended up scrapping it. I have the original Arrows SDD propeller over here. We've got the master air screw propeller that I run on the Prodigy and the Titan here. We've got a turbine for fun. I'm only running 3S, so that project didn't work out. Not enough power. Got 4 batteries that are charged up. I have a tachometer sitting here, and 2-blade, 3-blade, 4-bladed propellers for folding propellers that I had printed, as well as a whole stack of 3D printed props, everything from 6 to 12 inch, and some store-bought props, a couple of 5-inch, 5 1/4, and again the master air screw. So we're going to figure out how much torque these have for each of these motors. I've got a little 2212 1000, 2212 1500 from the Arrows Prodigy, 2212 2450, which is one of these little black ones, 3136 1000 that came out of the Arrows SDD 54. I had tried to order a replacement motor for that and got a 3536 by 1100 instead. I got here, I was quite happy, as they are quite a bit bigger, and I can still mount them to the airplane. So naturally the next step was to figure out the biggest 3536 that I could get hold of and buy it. That'll be this 1450. Not all of these props will fit all these hubs or all these motors, but I'll try to do the most complete test I can in the shortest amount of time. Before we really get going on this, I'd like to go over the propellers with you. I've got the one from the Arrows SDD 54, which is what really sparked my interest in that, because it's a $14 prop and I can print them for like 14 cents. I've got this little guy. It's a 5-inch. Just picked it up on Amazon. I was looking for a cheaper version than that. Turns out that's a 6-inch. And again with this, which is a 5 1/4, but we're getting closer. Anyway, I've got this El Cheapo 8-inch that just about everybody's got around. There's a turbine. That's the end of a project that I scrapped out. I don't have enough power in a 3S to run an EDF. We'll try that again later. I've got this 6-inch and this 6-inch on the mount, which are different prints. If you want to print one like this shape, oriented on the print bed vertically, I used this design and scaled it up to make those. And this one is the folding prop that I decided to go with. I got it off of Maker World. I like it better than that one I was using earlier. It's got a stiffer root here, a lot more material, so it's a lot stronger. The hole was a little bit too big for what I wanted. This is stock. So I made it smaller, made the blade a little bit wider, and then I cut it flat on it so that it would print off the bed like this. Very reliable that way. And I ended up with this thing. Now, it didn't have a spinner at all, so I wanted a hub and a spinner. Decided to make my own. This one I've got a little raised spot that corresponds with a notch, so you can get it in the center along with the hole for mounting it. However, we're not going to be using those during this test. There's no point setting them all up. Very excited to see how this all works out for thrust. I made a 2-blade, a 3-blade, and a 4-blade model, and I scaled them 80%, 75%, 60% for an 11 1/4, an 8, a 7-inch, and 8 1/2 on all 3 setups. So let's get some numbers on the paper. I just found one of those propellers I'd been talking about earlier, and much to my surprise, because I thought they were all thrown away. Anyway, like I said, it's got this rough surface on it, and we'll put it on the scale, but I was just not getting the kind of power I was hoping out of that. Alright, I got that 6-inch, since it's already mounted on a 2212 1000. Give me 150 grams. And let's find out the RPM. 11,278. 5 1/4 inch Amazon prop. Still with the 2212 1000. 11,368 RPM, 145 grams. Master air screw 6-inch. 10,875 and 110 grams. 8-inch El Cheapo. Okay. That one's got a little more power than I was looking for, and I missed the tachometer as well as the scale. That's because I got the damn thing on there backwards. Like I said, that's what that safety is for. Figured it out. Round 2 with the 8-inch. 8,900 and 545 grams. Put this 4-inch or 100 millimeter turbine on there next. 9,800 and 145 grams. The other 3D printed 6-inch. Yeah, I moved the tachometer so that my hand was no longer in line with these new experimental propellers. 11,037 and 185 grams. Moving up to the 7.5 inch 3D printed propeller. I think this is going to start to put a load on that little motor. We'll see what it'll do. 10,275, and turn the scale back on. Come on, hurry up. 355. That sounds like I forgot to balance that one. This is the 9-inch, and it's the biggest one that'll fit that hub. I'm guessing that's a bigger propeller than that motor's supposed to have anyway. 9,300, 535 grams. That's not bad. I would check that closer and see if that gets hot in a few minutes. For the sake of keeping the same motor on the same mount, we'll move on to the 2-bladed folding propeller at 60%, or from now on it'll be known as 7 inches. I'm used to using the percentages because I've been scaling them and working with them. Just once I complete the prop, then I can measure from the center to the tip and establish the size. 10,900 and 200 grams. That's pretty good. Moving up to the 75% side, I was playing around with some extra filament that I had laying around. Even though this is mounted in the hub backwards, you can still use the factory hub and put the cover on it. It'll all fit. 75% prop is an 8.5 inch, by the way. 9,500, and I need a new battery for that scale. 440 grams. It's an 80% size, or now 9-inch 2-blade folding propeller. Whoa! Okay, it was folded over the center. Turn it off, then correct the prop, and the now bent motor mount. Lots of power. Bent that up pretty good. You see why I'm so jumpy around these things. You could get hurt with these. All better try again. I noticed a flaw in the slot, as Roscoe P. Coltrane said. I had been writing the RPM down for this motor, and I didn't have a chart for the RPM for the other motors. So we'll just correct that now. Right, back to that 2-bladed folding prop, the 9-inch one. 5 529 grams and 9,000 RPM. Now the 11.5 inch two-bladed folding prop, but without that spinner on it. This is too big for that motor, but we'll run it anyway. Safety first. And 6,500 RPM. Moving on to the three-bladed folding propeller series, this is the 7-inch. $10,500 RPM and 220 grams. I was setting up the 8.5 inch, which would have been the 75% three-bladed folding prop with the hub, and I discovered that it will fit this one. This is the only version of what I like to call the claw, because it kind of looked like one with 4 blades on it. And I figure we'll give this a run. I didn't think I had a hub that would fit either one of those, but I do. So let's run it. $6,900 and 400 grams. Back to that three-bladed 8.5 inch. $8,700 RPM and 500 grams. I am noticing a little bit of warmth on that motor using these bigger props too. The 80% or 9-inch three-bladed folding propeller, I haven't developed a spinner yet for these. Once I figure out how to attach it to the thing, I will. Let's give it a whirl. $8,200 RPM, 580 grams. The 11.5 inch three-bladed folding prop is just enough room to mount the hub. And again, I was just using up a bunch of extra filaments that I had laying around. That propeller is of course way too big for that motor. It'd burn it up in pretty short order. $6,100 RPM. I get 790 grams out of it, surprisingly enough, but that wouldn't last for very long. And finally, the 4-bladed folding propellers, 7-inch, this would have been a 60%. $10,000 RPM and 270 grams. I expected more. 8.5 inch 4-blade folded propeller would be a 75%. $8,200 RPM, 530 grams. 80% 9-inch 4-blade foldable prop. That poor little tiny motor. $7,800 and 450 grams of thrust. The 11.5 inch 4-blade folding prop. This will be the 100% scale. $5,300 and 580 grams of thrust. You could hear it fading already. That concludes the test of the 2212 1000 kV. That's not kilovolts, that's 1000 RPM per volt on the battery, I believe. Moving on to what was the Arrow's Prodigy motor, a 2212 1500. Back to that little 5-inch we got from Amazon for the quadcopters. The view was a little bit far away from those propellers, so I reset everything. $16,800 and 350 grams of thrust. 5 1/4 inch fixed 3-blade from Amazon, again for the quadcopters. $16,800 and 345 grams. 3-bladed 6-inch master air screw propeller that taught me how to fly in the Arrows Prodigy. $15,600 RPM and 610 grams of thrust. 8-inch 2-bladed El Cheapo from Amazon. 1,020 grams and 12,000 RPM. The 4-inch or 100 millimeter EDF turbine blade. 13.6 and 295 grams. 6-inch 3D printed 3-blade fixed propeller. 16,400 and 340 grams of thrust. The other 6-inch prop. 15.9 and 405 grams of thrust. Unfortunately, Arrows likes to use proprietary spinners and hubs on their motors, and that makes it so none of my other fixed bladed propellers will fit. However, some of the folding props will, so we'll move on to those. We can get started again with the 2212 1500 from the Arrows Prodigy with the 7-inch 60% 4-blade folding propeller. That's a mouthful. Never mind, those won't fit either. Good job, Arrows. Okay, I guess we'll just move up to the 2212 2450 kV motor. That was the trouble with the Arrows mount. You can't do a whole lot with it. Anyway, back to the Amazon 5-inch. $405 grams and 22,400. The 5 1/4 inch Amazon 3-bladed fixed propeller. $670 grams and 22,200 RPM. The Master Air Screw 6-inch 3-bladed fixed propeller. $18,500 RPM, 420 grams of thrust. The 4-inch 100 millimeter turbine blade. I don't trust this thing. Stuff's blowing my bathroom wall all over the place. Yep. Safety. Glad I put that there. Try that again, then change the battery. Oh, re-aim the laser. There we go. 385 grams of thrust, 16,000 RPM. The 8-inch orange El Cheapo. Okay, about that battery. 1,400 grams and 14,000 RPM. Gonna have to let that motor cool off. It's getting too hot. You could probably hear it fall off of there and I can start to smell it. 6-inch 3-bladed fixed 3D printed propeller A. $725 grams and 22,400 RPM. 6-inch 3-bladed 3D printed prop B. 21,000 RPM. Sounded absolutely horrifying. 40 grams. Yikes. 7.5 inch, 3-bladed, 3D printed fixed propeller. 1,100 grams of thrust. 17,200 RPM. 9 inch, 3D printed, 3-bladed, fixed prop. That last run got that motor pretty warm. 14,000 RPM, 1,400 grams of thrust. Motor's getting hot again. We'll let it cool off. Meanwhile, I've got the 7 inch folding 2-bladed propeller. Figures just about the time I'm seeing numbers I like, the motor starts to overheat. 685 grams of thrust, 20,000 RPM. I got a 75%, 8.5 inch folding 2-bladed propeller. Just over 1,000 grams and 15,000 RPM. A little bit bigger with the 80%, 9 inch 2-bladed folding propeller. 1,100 grams, 12,000 RPM, and it's not liking that. Yeah, the motor's too hot to touch, so I put one of those little 5-inch props on it to cool it off. Next, we'll do the 3-bladed, 3D printed folding propellers, and I think mercifully we'll leave the full scale prop off of that motor. 18,900 RPM and 695 grams of thrust. The 8.5 inch, 75% 3-bladed folding 3D printed propeller. 12,500 RPM, 1,080 grams, and start to hear it fading. The 9 inch 3D printed 3-bladed folding propeller, one step higher than I should probably put on that motor. Maybe two, probably two. Yeah, not good. 810 grams of thrust, 11,500 RPM. The last propeller I'm going to run on this particular motor is the 7 inch, 60% 3D printed 4-bladed folding prop. There's no point running it any harder than that. It's already overheated from that last run. I gave that thing a few minutes to cool off. 17,300 RPM, and I have it set in Imperial. 810 grams of thrust. We're making great progress with this project. We're about halfway through it. I deleted this one. It was the 11.5 inch 5mm shaft folding 2-bladed 3D printed propeller. The motor was just way too hot. There's no point in keeping the information. Now that I've almost completely burned up that little 2212 by 2450, we'll move on to the Arrow's SDD54 power plant, the 3136 1000. So the 6 inch 3D printed props won't fit on that. Neither will the Master Air Screw 6 inch or the 5 1/4 or the 5 inch from Amazon. And neither will that. The El Cheapo 2-blade Amazon prop actually made the running. 9,800 RPM and 620 grams of thrust. With a slight hole size in the center, we can use the 7.5 inch 3D printed 3-bladed prop. Pretty sure this is the one that was off balance. 405 grams of thrust and 10,900 RPM. Moving up to the 9-inch 3D printed 3-bladed propeller. 630 grams of thrust, 10,000 RPM. The 10-inch, the 11.5, and the 12-inch 3D printed 3-bladed propellers are all sized for a larger prop shaft size. Since the hub design led us to only one propeller for the full-scale 2-bladed folding propeller test, we might as well just use the Arrows SZD54 factory prop, the claw that got discontinued, and then my propeller design. Arrows SZD54 stock 12-inch propeller. 1,220 grams, 7,500 RPM. And now for the 12-inch claw. 8,000 RPM, 685 grams of thrust. 1,000 grams and 7,700 RPM. 3-bladed 8.5-inch folding propeller. 600 grams of thrust, 9,400 RPM. 3-bladed 9-inch 3D printed folding propeller. 700 grams of thrust, 8,900 RPM. And the full-size 11.5-inch 3D printed 3-bladed folding propeller. Be changing the battery again after this one. 6,800 RPM and 1,050 grams of thrust. Motor temperature is still good, by the way. The 9-inch 4-bladed folding 80% prop. 820 grams and 9,100 RPM. The full-size 11.5-inch 4-bladed 3D printed folding propeller. 1,170 grams and 6,600 RPM. That concludes the test of the 3136-1000 for the Arrows SZD54. Now we move on to the 3536-1000, which I thought was an exact replacement, but happily it's bigger. It's like sticking a V8 where a V6 used to be. I expect to see very similar numbers between the 3136-1000 and the 3536-1100, as the second number is a closer correlation to your RPM. I'm expecting more torque out of the 3536, obviously. We'll get things started off with the 3536-1100 with this 3-bladed 3D printed 7.5-inch fixed blade propeller. I wound up using that little skirt part behind the propeller on that shaft to make up a little gap with the diameter. Is perfect. $510 grams of thrust, 12,500 RPM. A 9-inch 3D printed 3-bladed fixed propeller. 830 grams of thrust and 11,200 RPM. Now for the 3 12-inch folding props. I wound up using that little skirt again to mount this prop too. Yeah, that's why I stand behind that thing. Yikes. That was laying on the ground with the 4 screws attached. Hopefully it's not bent. I got that bolted down this time. I won't do that again. Yeah, there's that little collar still on that shaft. I managed to find pieces of that propeller. That's one reason I wanted a root and a mount that were nice and thick. Like the injection molding on the SZD isn't too bad, but compared to this 3D print, I'm liking that a lot better. It's just got a lot more meat to it. Anyhow, back to the testing. The Arrow's SZD54 factory propeller. It's a 12-inch. 1,620 grams that time. 8,900 RPM. Very nice. 3D printed 11.5-inch 2-blade folding prop. 1,400 grams of thrust and 8,900 RPM. Now we can spin the 8.5-inch 75% 3D printed 3-bladed folding propeller. .780 grams of thrust and 10,500 RPM. A lot more torque to pull the thing through the atmosphere with. The 9-inch 80% 3D printed 3-bladed folding propeller. 930 grams of thrust and 10,300 RPM. 11.5-inch 3-blade folded 3D printed propeller. 1,500 grams at 8,100 RPM. And now for the 4-bladed propellers, 80% or 9-inch 4-bladed folding prop. 730 grams of thrust and just a little above 10,000 RPM. The 100% 4-bladed folding 11.5-inch prop. 1,160 grams and 7,500 RPM. That concludes the testing on the 3536 1100 kV motor. And now we'll install the 3536 1450 kV motor. With that 3536 1450 in place, I can now move up to the 8mm hubs and the big 3, which are the 3D printed 3-bladed fixed 12-inch, 11.5, and 10-inch propellers. I have finally, I think, successfully built the hub for the full-size 3-bladed 8mm folding propeller. It's in the printer now. We'll begin testing the 3536 by 1450 with the 10-inch 3-bladed 3D printed fixed propeller. 11,300 RPM and 1,550 grams of thrust. That's a good start. The 10-inch 3-blade 3D printed fixed propeller. 1,800 grams and 9,500 RPM. Seems like it's starting to load the motor again. It's only the second time I've spun that, so I don't really have a feel for it yet. The 12-inch 3D printed 3-blade fixed propeller, I can make it about 12 3/4, but that's about the maximum for the printer, but I never thought that this motor was supposed to push that anyway. That motor was a little bit worn from those last 2 run-ups. 1,980 grams and 9,500 RPM. And I'm thinking that's too much. Next up will be the 11.5-inch 3D printed 2-bladed folding propeller that I got off Maker World. 1,780 grams and 9,600 RPM. This is my 3D printed two-blade folded propeller in 8mm. 1,700 grams of thrust, 9,800 RPM. The 50mm just kidding. The 9-inch 4-blade 3D printed folding propeller. 1,300 grams and 11,000 RPM. The 11.5-inch 4-blade folding 3D printed propeller. I'm guessing this thing's also too big. We're just waiting for the 3-bladed full scale to come out of the 3D printer. $1,700 grams of thrust and 7,800 RPM and the end of that battery. I ran this propeller after going over the numbers, hoping that it was going to be the replacement for the SZD stock propeller, but it got the motor too hot and the SZD propeller wouldn't fit. So the 3-bladed prop that's in the printer right now will also get this motor too hot. I'm going to re-examine the 9-inch folding prop as well as the 9-inch fixed prop, and I really liked what I saw on the 9-inch 4-bladed prop. The 10-inch prop, the fixed prop, I think is going to be too much of a load as well. I'm going to try it again. The only trouble with the 9-inch fixed prop is that the hub size doesn't fit yet. And if I can fix that, I'll give it a run. Okay, I got a drill. Yeah, I know that's the fastest way to lose concentricity, but it's faster than a 3D printer. But I got a drill and I made this hub fit. Let's give it a spin and see if it'll run. The 9-inch folding propeller was one of my personal favorite, hopefuls for the SZD project. 1,350 grams and 12,000 RPM. Let's see if it gets hot. Full-size 3-bladed folding prop just came out of the printer. I'm not going to run it. There's no point in putting it on that motor. I ran that 9-inch for about a minute and a half, and it got the motor pretty warm. The base plate was quite hot, which is a little strange because with a check mark, it shows that I'm within the acceptable thrust range of this motor, except that I don't like the heat, which tells me that the 9-inch fixed, the 9-inch 4-bladed folding, and the 10-inch fixed are all going to get that too hot as well. So at this point, I'm going to review these notes and see what we got. I decided to go ahead and grab the drill, punch a hole in that 9-inch fixed 3D printed prop, and see what we get. Let's take it for a spin. Only getting 500 grams out of it? It's like 12,000 RPM. That's weird. Don't know. I'm still not giving up on my propeller. I was looking at this really close, and the SZD prop and my prop are just about the same pitch, almost the same dimension, but my white one is wider. So, like a parakeet, I clipped its feathers. I like this one, but it's too skinny. I liked it because it would print with almost no support. However, this one I think is going to be a little bit better, and I moved the cut angle this way, which means I have support, but I've got a better airfoil. So we'll see what it does on the scale. That just finished up. Those are the clipped propellers for the 11.5-inch. this design because they come right off the print bed. You just sand the trailing edge to establish balance. The 2-blade clipped 8mm 3D printed folding propeller. RPM and 1,575 grams of thrust. I was thinking, I got a couple of those hubs nailed to that tree out in the backyard. By the way, happy Easter. And if I screw up by getting one of these off the center, it'll be okay. So, I'm going to mount this SCD prop to that 35, 36, 1450, and judging by the numbers on that paper, this is probably going to be the propeller if it doesn't come apart. That is only after I get it put together in the right direction. The pitch of the blade on the SCD and the 2-bladed folding propellers is pretty much the same, if not identical. 2,200 grams of thrust and just over 10,000 RPM. Yeah, that's our prop. From 1,227, that is going to be one heck of a kick in the pants. After a couple of weeks of running the 3D printer, over 1 kilo of filament, about 100 hours in the studio, a couple of days shooting video, I've got a really nice list here that I could use for a cross-reference of what motors go with what propellers, how much power I get, whether I'm going to burn something up while I'm trying it. The 3-bladed 9-inch, I think that'll still fly even though I'm getting the motor kind of warm. The same thing with the 4-bladed, but I don't think I'm going to run this one on the SCD-54. I'll be running the factory prop on that for the most part. I cannot argue with the numbers as badly as I wanted these to work. You can't argue with the math. And I can't even be disappointed because, oh my gosh, I'm almost doubling the power of this airplane. It's going to be so much fun. Anyway, if you're still here, thank you for your patience and thank you for your attention to this matter.